Have you ever tried splitting a restaurant bill among three friends in just the right way? Well, factorizing trinomials is kind of like that. You're trying to split an expression into just the right parts that perfectly multiply back to the original. In this topic, we'll learn how to factor expressions of the form ax squared plus bx plus c, where a, b, and c are real numbers. These are called trinomials, three-term algebraic expressions where the highest degree of the variable is 2. For example, x squared plus 9x plus 18 is a trinomial. The goal is to break it into two brackets, each of which is a binomial, that means two terms per bracket. Let's learn how to do that step by step. To factor a trinomial like ax squared plus bx plus c, we use the splitting the middle term method. Here's the idea. We try to split the middle term, bx, into two terms mx and nx, such that m plus n equals b and m multiplied by n equals a multiplied by c. Let's write that as m plus n equals b, m times n equals a, c. Once we find the right m and n, we rewrite the expression as ax squared plus mx plus nx plus c. Then we group terms in pairs and factor using common terms. This method works very well for most factorable trinomials. But before we jump into splitting, let's quickly check whether the trinomial can be factorized at all. For the general expression ax squared plus bx plus c, calculate the discriminant d equals b squared minus 4ac. Now here's the rule. If the discriminant is a perfect square, then the trinomial can be factorized using real numbers. If not, the expression may not factorize using integers, and we might need to use quadratic formula methods instead. So checking the discriminant can save us time before we begin. Let's work through a simple example. We are given the trinomial x squared plus 9x plus 18 here, a equals 1, b equals 9, and c equals 18. We want to find two numbers whose sum is 9 and product is 18. By trial, 3 plus 6 equals 9 and 3 times 6 equals 18. Perfect match. Now, rewrite the expression by splitting the middle term, x squared plus 3x plus 6x plus 18. Group terms, open bracket x squared plus 3x close bracket plus open bracket 6x plus 18 close bracket. Factor x into bracket x plus 3 plus 6 into bracket x plus 3. Final answer, open bracket x plus 3 close bracket into open bracket x plus 6 close bracket, and that's our factorized form. Now let's take one with a negative middle term. We are given y squared minus 3y minus 54. Here, a equals 1, b equals minus 3, and c equals minus 54. We need two numbers whose sum is minus 3 and product is minus 54. Let's try 6 and minus 9. 6 plus minus 9 equals minus 3. 6 times minus 9 equals minus 54. Yes, these are our values. Split the middle term, y squared plus 6y minus 9y minus 54. Group terms, open bracket y squared plus 6y close bracket minus open bracket 9y plus 54 close bracket. Factor y into bracket y plus 6 minus 9 into bracket y plus 6. Final factorized form, open bracket y plus 6 close bracket into open bracket y minus 9 close bracket. Again, perfect factorization. Let's quickly revise what we've learned about factorizing trinomials. We focused on expressions of the form ax squared plus bx plus c. To factorize, find two numbers whose sum is b and product is a multiplied by c. Split the middle term using these numbers. Group and factor. Optional, use the discriminant test d equals b squared minus 4ac to check if factorization is possible. This method is powerful and appears everywhere in algebra, from solving quadratic equations to simplifying expressions in coordinate geometry. And that's the foundation of how we factorize trinomials using the splitting the middle-term method. In the next video, we'll explore how to factorize special cases like sum or difference of two cubes and connect it to completing the cubes. See you there.